In cloth manipulation, a common assumption is to fix the trajectory between predefined pick-and-place positions. However, given a fixed trajectory, the folding outcome depends on the cloth physical properties, such as how stiff the cloth is. In this case, the stiffer cloth was better folded with respect to the less stiff cloths. If we were able to adapt the folding trajectory in a feedback loop fashion, we could potentially improve the folding outcome of the two cloths. However, choosing a proper representation to perform feedback loop is fundamental. While particle-based representation, such as point clouds, can be easily tracked during the manipulation loop, they fail to accurately describe the quality of the fold. We then augment the point clouds with descriptors about the upper and the bottom layer of the cloth. And we propose AdaFold, a model-based feedback loop framework to plan pick-and-place trajectories. We use point cloud augmented with the layer labels and data-driven model predictive control to optimize the folding trajectory. To test AdaFold, we select 6 different real-world cloths with different physical properties. And first, evaluate the performance of a triangular trajectory. We then optimize the trajectory with AdaFold. While the triangular trajectory yields different outcomes based on the properties of the cloth, AdaFold successfully optimizes the folding trajectory for all the samples. Come to the poster session if you want to know more about AdaFold.